I'm going to talk about geometric sequences. I'll assume that you know the basics of sequences. If you don't, I would invite you to watch the necessary videos. So let me now define what a geometric sequence is. A geometric sequence is a sequence in which every element is the previous element multiplied by the same factor. Equivalently, a geometric sequence is one in which the ratio of any element and its previous element is the same. Okay? Here are some examples. Okay, so that is a geometric sequence because every element is 2 times the previous element. Okay, also the ratio of any element to its preceding element is 2. All right, here's another geometric series example. All right. Now, the reason that this one is a geometric series is because every element is the preceding element multiplied by 1/10, right? Equivalently, the ratio of every element to the preceding element is 1/10 or 0.1, okay? So geometric sequences can be increasing, they can be decreasing, they can also be neither increasing nor decreasing. Let me show you an example of such a geometric sequence. Okay, so the sequence where the elements alternate between 1 and -1, the reason that that's a geometric sequence is because it meets all the requirements. Notice that every element is equal to the previous element multiplied by the same number, in that case -1. Equivalently, notice that the ratio of every element to its previous element is the same. In other words, -1. All right? Now I'd like to show you what the functional description for a geometric sequence always looks like. So every element is some number multiplied by the previous element. So if the first one is A1, the next one will be A1 multiplied by, let's call it R for ratio. R is the ratio of every element to its preceding element. Then the next one will be that A1R times another R, so A1R squared, and then A1R cubed, and so forth. Okay, so hopefully you can see that for a geometric sequence, the functional description will be A sub n is equal to the first term times R to the n minus 1, where n is equal to 1, 2, 3, and so forth. Okay, so there's the non-recursive functional description. Okay, now we can also get the pattern for the recursive functional description as well. So every element, as I've said already more than once, every element is equal to the preceding element times the same constant, which I'm calling R. So clearly we have this recursive function relation. And this is true for n equal to 2, 3, 4, and so on. And we've got to then define a sub 1 as well as giving this formula. Okay? So make a note of these patterns, and let's do some example problems now. So suppose we wanted to determine the 10th term of this sequence. Okay? So because I can see that it's a geometric sequence, and I hope you can see that as well, we can use the functional description to make finding the 10th term easier. So a sub n is equal to the first term times 3 to the n minus 1. Okay? And so if we want the 10th term, a sub 10, that's equal to 4 times 3 to the 10 minus 1, which is 4 times 3 to the 9. And you can multiply that out or use a calculator, and you'll see that that is 78,732. All right. So here's another exercise that I'll go ahead and show you how to do it. You can be given a sequence such as this one. All right, and you might wonder if it's a geometric sequence or not. Okay, so can you determine if it's a geometric sequence or not? You might want to see if you can answer that now. So this is not a geometric sequence. Okay, the answer is no. Why? Because if you take the ratio of the second term, the second element to the first element, you get 2. But if you take the ratio of the, let's say, the fourth element to the third element, you do not get 2, right? But for a geometric sequence, you need to get the same value all the time. All right. If you're curious, this is an example of an arithmetic sequence. All right. Now, let me have you try to do some exercises. Can you tell me which of these two sequences, if any, are geometric? Okay, there's one, and then okay, so pause the video and see if you can determine for each one whether it's a geometric sequence or not. So do that now, please. All right, so I'll go ahead and work it out as well. So the ratio of every element to the preceding element is not the same for all elements of the first sequence. For example, the fifth element divided by the fourth element is equal to a half, but the third element divided by the second element does not equal 1/2. So that one is a no. It's not a geometric sequence. Okay? Now, for the second sequence, that ratio, minus 10 over 1, is equal to 100 over minus 10. That ratio is the same. It's always minus 10. So that one checks out, so that gets a yes. All right? Here's another exercise to make sure you understand the basics of geometric sequences. Can you tell me what the first 5 terms of the geometric sequence, such that the first term, a sub 1, is equal to 40, and that ratio r is equal to 1/2. Okay, so I want the first 5 terms. So pause the video and see if you can determine those now, please. Okay, I'll go ahead and do it. So what you do is you start with 40, of course, and then you multiply it by a half to get 20, multiply it by a half again to get 10, then 5, then 2.5, and lo and behold, we have 5 terms. It's no more difficult than that. Okay? Let's do one more. So suppose that I had the following sequence. 0.25, 0.5, 1, and so on. And I wanted to know what the 10th term is. Pause the video and see if you can determine that now, please. All right, I'll go ahead and do it as well. So this is a geometric sequence. R is equal to 2. A1 is equal to a fourth, or 0.5. So A sub n is equal to, let's see, 1/4 times 2 to the n minus 1. So we're looking for the 10th term. I could simplify the functional description, but I may as well go ahead and replace n with 10 first. So a sub 10 is equal to 1/4 of 2 to the 10 minus 1. That's equal to 2 to the 9 divided by 2 squared, because 4 is equal to 2 squared, right? So that's equal to 2 to the 7th, which is 128.